everyone, welcome to Math Advice. In this video, let me discuss an example and a odd and even function in Fourier series. For that, let me take an example. Expand f of x equal to x as a Fourier series in an interval minus pi comma pi and deduce this result 1 minus 1 by 3 plus 1 by 5 minus etc. that is equal to pi by 4. So before let me enter into the problem, let me have a short look over the important formulas that we are going to use in the problem. So the very first important formula you should know is Bernoulli's formula, that is integral u v dx is equal to u v1 minus u dash v2 plus u double dash v3 minus etc. So we make use of this formula whenever we have the product of functions in an integral. So in an integral, if there is a product here, both u and v are functions of x. So if it is a product of functions, then we make use of the formula to evaluate the integral. And this goes up to infinity. So we stop the procedure whenever the derivative becomes 0. Okay. So here both the u and v are functions of x. Here u dash, u double dash, etc. are successive derivatives of u, whereas v1, v2, v3, these are successive integrals of v. So u dash means you have to differentiate u with respect to x once. U double dash means you have to differentiate u twice with respect to x. Like that, v1 is nothing but integral v dx. v2 is nothing but integral. Again you have to integrate v1 once again. That is v2, right? So v3 means integrate v2 once again with respect to x means that's your v3, that's your etc. Okay. So the next one, the basic formula is for integral, that is integral x bar n dx is equal to x bar n plus 1 divided by n plus 1. That is, if you integrate x square, what happens? X square dx is nothing but x cube divided by 3, is it? 2 plus 1 is 3, isn't it? So if it is for differentiation, d by dx of x bar n is equal to nx bar n minus 1. Suppose if you are differentiating the same function with respect to x, what happens? That is nx power n minus 1, n is 2. So 2x power 2 minus 1, that is 2x, right? Next one, integral sin nx value nx dx is equal to minus cos nx divided by n, whereas integral cos nx dx is equal to sin nx divided by n. And limit value also you should know, that is you know the value of cos 0. The value of cosine 0 is 1, whereas cos n pi is equal to minus 1 whole power n, whereas sin 0 is 0 and sin n pi value is 0 whenever n is an integer. Here we have to discuss only integer values, so sin n pi value 0. So now let me move on to the problem. This one, the given problem, expand f of x is equal to x. The given function is x as a Fourier series in an open interval minus pi comma pi and deduce this result. First what we are going to do is, first we have to find out the Fourier series representation of the given function f of x is equal to x. So the given function is f of x is equal to x, that is given in an interval. So you have to write the you have to write the function along with the interval, that is must. Okay, in the reduction part we make use of the interval whether it is open or closed. Okay, now so the given function is f of x equal to x in minus pi comma pi, as I told you already. So whenever you see the interval is from minus pi to pi or from minus L to L, so there is a case of odd and even arise. So this is not the case for 0 to 2 pi, or you have to deal with the problems that are 0 to 2L. So the case of odd and even function doesn't exist for these two intervals. The cases of odd and even function exist for only these two intervals, from minus pi to pi or minus L to L. Here the function is defined in the interval minus pi comma pi. Whenever you see the interval is from minus pi comma pi, immediately you can verify whether the given function is of odd or even. So based on that, we have separate formula for finding out the Fourier series representation of the given function. Okay, so to find out whether the given function is of odd or even, what we do? So just replace x by minus x. Now what you are going to do, just replace in the given function, you have to replace x by minus x. If you replace x by minus x, what happens? So given function f of x is equal to x. So replace x by minus x means just you have minus x alone. So minus x is nothing but what is it? That is minus of x is nothing but your given function f of x, right? So f of minus x equal to, so which means, what it means, f of x is an odd function, isn't it? How? Because whenever you see the result f of minus x equal to minus f of x, that gives me a result that f of x is an odd function. Instead of that, if you get f of minus x equal to plus f of x, means that is an even function. So here we get f of minus x is equal to minus f of x. If so, the given function is of odd type. So if it is an odd type, odd function, immediately you can write then the values of a0 and an 0. So no need to calculate the values of a0 and an due to the given function is of odd type. So the Fourier series, let the required Fourier series be Fourier series be of the form f of x is equal to, it consists of only bn alone, because a0 and a becomes 0, so you can have only bn term, that is sigma n raised to 1 to infinity bn sin nx. So you can calculate the value of bn by making use of the formula bn is equal to 2 by pi integral 0 to pi f of x sin nx dx. So after calculating the value of bn, you can substitute this value in equation 1. Right? Take this as equation number 1. So what is your f of x? Now directly we can calculate it here. So what is your f of x? That is bn is equal to 2 by pi integral 0 to pi. Your f of x is nothing but given function, that is x sin nx dx. So this is both x and sin x, both are functions of x. So if so, we make use of the Bernoulli's formula, you know already. So you have to take the first function as u and the second one as v. So if so, you have to calculate u dash. So separately I have to calculate this. So if you are well versed about the formula, you will go ahead with the formula derivation. Okay. So u is equal to x and v is equal to sin nx, isn't it? So what is your u dash? U dash is differentiating. So when you differentiating x, you get 1. U double dash means when you differentiating a constant, you get 0. Next, v1. So since u double dash becomes 0 means you can calculate up to v1, v2. That's enough, right? So v1 is nothing but is integrating sin nx. What is integral sin nx dx? Integral sin nx is nothing but minus cos nx divided by n. Next, you have to integrate v1 again with respect to x. So here minus 1 by n is a constant. So integrating cos nx, you get sin nx divided by n. So sin nx divided by, already you have n in the denominator, so n square. So shall we substitute in the formula? So bn is equal to 2 by pi. So u v1, what is the formula? U v1, what is your u? X. v1 is minus cos nx divided by n minus u dash is 1. v2 is minus sin nx divided by n square. Okay. So we don't have the next term because u double dash becomes 0. So we have to stop up to this. So with the limit from 0 to pi. So before substituting limits, let us simplify. This minus and minus as plus. So 2 by pi, and take this minus to the front. So minus x cos nx divided by n plus sin nx divided by n square with the limit from 0 to pi. So as usual, let me substitute the limit, that is upper limit minus lower limit, isn't it? This is what the usual procedure we have to follow. So first one, upper limit, that is you have to replace the values of x by pi first. So if you replace the x value of x by pi, minus pi cos n pi, you know directly I am going to simultaneously I am going to replace the value of cos n pi by minus 1 whole power n, isn't it? Cos n pi value is minus 1 whole power n divided by n plus sin n pi. You know the value of sine n pi. If you replace this x by pi, you get sine n pi. The value of sine n pi is 0. So 0 by anything? 0. Upper limit over. Minus. Coming to the lower limit, in the lower limit you have to substitute 0 for x. So if you replace this x by 0, so you get 0 into anything. You know the value of cosine 0. Cosine 0 1, but it is multiplied with 0. 0 means 0 itself plus sine n 0, that is 0. Sine 0 value is 0. So there is no value for lower limit. So let me simplify this. 2 by pi minus pi minus 1 whole power n divided by n. So pi and pi being cancelled. So shall I combine this minus with n? I am going to write this as 2 by n minus 1 whole power n plus 1, because this is minus 1 whole power n, and I am having one more minus. So I have to add this with minus 1. So I have minus 1 whole power n plus 1. So this is the value of Bn. So let me substitute in equation 1. So then here f of x is equal to sigma n varies from 1 to infinity Bn sin n x, isn't it? So the value of Bn is 2 by n minus 1 whole power n plus 1 sin nx. Next, here you have to take the constant outside of the summation. 2 alone be a constant, so take it outside of the summation. So sigma n varies from 1 to infinity minus 1 whole power n plus 1 divided by n sin nx. This is what the Fourier series representation of the given function f of x is equal to x. So then next one, what we are going to do is we are going to deduce a series of the form 1 minus 1 by 3 plus 1 by 5 minus etc. that is equal to pi by 4. So we are going to deduce this series. So you know already what is the given function. Given function is f of x equal to x in an interval minus pi comma pi, in an open interval. More clearly, that is of open interval minus pi comma pi. So as I told you already, sine series in most of the cases, okay, in most of the cases sine series is obtained by putting x is equal to pi by 2. So take your first choice as x equal to pi by 2, then go for the next choice, okay. So most of the problems in Fourier series, sine related series, okay, sine related series are obtained by substituting x equal to pi by 2, okay. So now what we are going to do next is, so this is what I am going to write out the general Fourier series representation here. So f of x equal to twice sigma n varies from 1 to infinity minus 1 whole power n plus 1 divided by n sin nx, isn't it? So now what we are going to do is put x equal to pi by 2. If I am going to substitute f equal to pi, what is your given function? F of x equal to x. In which interval? Minus pi comma pi. So after taking the point x equal to pi by 2, you have to verify whether this is of continuous type or discontinuous type. So pi by 2 is inside the interval, isn't it? Minus pi in the interval. If it is minus pi plus pi means pi by 2 is approximately here, isn't it? So that is a continuous point, isn't it? So that is a continuous point. If it is a continuous point, so you can find the value of f of x at x equal to pi by 2 by just by replacing the value of x by pi by 2. That's enough, okay. So put x equal to pi by 2, which is a continuous point, then we have f of x at x equal to pi by 2. Or you can write this as, just replace x by pi by 2. In these two places we have x. Or you can write this as f of pi by 2. Both are same, okay. More clearly I have tried this as f of x at x equal to pi by 2. Or you can write it as f of pi by 2. Both are one and the same, okay. That is equal to twice sigma n varies from 1 to infinity minus 1 whole power n plus 1 divided by n sin n pi by 2. So we have to replace x by pi by 2, okay. So after doing so since it is a continuous point, so you have to replace the value of the function in f of x by pi by 2, okay. So the given function is f of x equal to x. If you replace x by pi by 2, what happens? You get only pi by 2. isn't it? Since f of x equal to x, replace x by pi by 2 means pi by 2 only you can get. That is twice summation. So here what I am going to do is first we have to expand the series. Okay. So leave the summation, just put a bracket. So n equal to 1. First substitute n is equal to 1. If you substitute n is equal to 1, what happens? Minus 1 whole power 1 plus 1. That is minus 1 square. 1 square is 1. Divided by 1 is 1 itself. I am just writing here. 1 by 1 sine pi by 2. What is the value of sine pi by 2? You know already sine pi by 2 value is 1 plus. So substitute n is equal to 2. If you substitute n is equal to 2, what happens? 2 plus 1, 3. That is minus 1. Minus 1 whole cube is 3. Divided by 3 sine, divided by 2 sine 2 pi divided by 2. Plus substitute n is equal to 3. If you substitute n is equal to 3, what happens? So minus 1 whole power 3 plus 1 is 4. That is even. Even means plus 1. Divided by 3 sine 3 pi by 2. The next term is plus. Substitute n is equal to 4. N is equal to 4 means 4 plus 1, 5. Odd. Odd number means you can get minus 1. So that is divided by 4 sine 4 pi by 2. Plus the next term is substitute n is equal to 5. If you substitute n is equal to 5, what you get? 5 plus 1 is 6. That is even. 1 divided by 5 sine 5 pi divided by 2. Plus. So next if you substitute n is equal to 6, n is equal to 6 etc. So we have to take up to 4 to 5 terms at the beginning of the series. No need to write it all. So this one the series we have obtained after substituting the values of n is equal to 1, 2, 3 etc. So you know the value of sin n by 2. What is the value of sin n by 2? Sin pi by 2. The value of sin pi by 2 is plus 1. Okay. Next, sin 2 pi by 2. 2 pi by 2 is nothing but sin pi. The value of sin pi is 0. Next, sin 3 pi by 2. The value of sin 3 pi by 2, that is sin 270. The value of sin 3 pi by 2 is minus 1. Next, sin 4 pi by 2. Okay. The value of sin 4 pi by 2 is nothing but sin 2 pi. You know the value of sin n pi. Sin n pi is 0. So this term 0. Next, sin 5 pi by 2. Sin 5 times pi by 2 is nothing but sin 4 times means one rotation over 5 pi by 2 is nothing but pi by 2. The value of sin pi by 2 is nothing but plus 1. Okay. Shall we replace all these values of sin with values? So that is pi by 2 is equal to twice. So within parenthesis, first term is 1 by 1. Product sin pi by 2 is 1, isn't it? So that is 1. So the first term is 1 plus. Coming to the second term, minus 1 divided by 2 sin pi. The value of sin pi here is 0. So product of anything is nothing. 0 with anything, 0. So you get the second term 0. Coming to the third term, so here you have minus 1. If you multiply this with 1 by 3, you get minus 1 by 3. So minus 1 divided by 3 plus, coming to the next term, sin 4 pi by, that is sin 2 pi. Here the sin value of 2 pi is 0. 0 into anything, 0. So in the next term, 0. Plus, coming to here, 1 by 5 sin 5 pi by 2, that is 1. 1 product, 1 by 5 with product with 1, that is 1 by 5. 1 by 5. The next term is minus, isn't it? Etc. So that is equal to twice 1 minus 1 by 3 plus 1 by 5 minus etc. That is equal to pi by 2. What I am going to do here is keep the series on this side, take this term to other side. So you can get, so I am going to write the series first, 1 minus 1 by 3 plus 1 by 5 minus etc. That is equal to pi by 4. This is for the required series. Okay. So up to this, hope you got a clear idea about how to find the Fourier expansion when the given function is of odd type. Thanks for watching. See you all again in my next video.